Okay, so we would be talking about rate of reaction today. And the simple definition of rate of reaction is the speed at which a reaction would take place. And there are many factors which affect the rate of reaction. And we will start with concentration. So if you increase the concentration of any one of the reactants, the rate of reaction would increase as there would be more collisions taking place. Okay, sorry, let's make this bigger. There'd be more collisions taking place. For example, if we look at situation A and B, we can see that reactant number one and reactant number two. Now, if we increase the concentration of reactant number two, the rate of reaction would be greater because more particles are present in like reaction B. And therefore, there would be greater collisions which would take place, and there would be a higher rate of successful collisions, therefore increasing the rate of reaction. Number two, we'll talk about pressure. And the greater the pressure, the higher the rate of reaction. This is because when there is greater pressure, as seen in situation B, particles are way closer together, and this forces them to collide more. And when they collide more, there's a higher chance of successful collisions, and therefore the rate of reaction would increase as there would be more successful collisions per second. Number three, we will talk about surface area, but this is only for solid reactants. And when there is increased surface area of a solid reactant, the rate of reaction would increase. The definition or like the basic understanding of increased surface area would be if a reactant is in a powder or like a granulated form, okay, then only will it have an increased surface area. Let's take an example. So if we look at the example for magnesium reacting with hydrochloric acid, if we use powdered magnesium, it will have a higher rate of reaction than if we use strips of magnesium. This is because powdered magnesium has a greater surface area and it allows more hydrochloric acid to react with it, and therefore it would have a greater rate of reaction. Number four, we'll talk about temperature. This is very self-explanatory as obviously the greater the temperature, the greater the rate of reaction. This is because when there is greater temperature, their particles and molecules have higher kinetic energy and they begin to move at greater speeds, as you can see in this figure. At room temperature, the particles' kinetic energy was low. However, when the temperature increased to 95, they started vibrating more vigorously and therefore collided with each other more, leading to greater rate of reaction. Lastly, presence of a catalyst would also increase the rate of reaction. And a catalyst is a substance which, again, like I said, increases the rate of reaction, but it doesn't be consumed. And it increases the rate of reaction as it provides an alternative reaction pathway. Some examples of catalysts are transition metals. Okay. Next, we will talk about how do you measure the rate of reaction. But it's important to keep in mind that these two methods can only be used if there is a gas being formed as a product. So we will be talking about the mass method as well as the volume of gas collected method. So firstly, we will be looking at the mass method. And this is when you have a weighing scale, a conical flask, two reactants. In this case, we'll be using hydrochloric acid and calcium carbonate. You'll have cotton, and this cotton bud will allow the gas to escape. And okay, so firstly, what you will do is you'll measure the mass of this apparatus before the reaction starts. And you'll measure it. But the minute the reaction starts, you'll start the timer and you will then periodically measure the mass. And you can see that after 10 seconds, the mass from 50 decreased to 45, after 15, 42, 20, 38. This is because CO2 is being released and therefore the mass would decrease of the entire system. You can even notice that after a while, the mass remains constant as it just plateaus at like 35. This shows that the reaction has stopped because there is no more product being formed. And once you have like a basic table, you can plot it, mass against time, and the gradient of this graph would equal the rate of reaction. Now, the second method is the volume of gas collected. Again, you'll need two reactants which would make a gas, and you would at times you'd start the time when they start reacting, and you would begin to plot the amount of gas collected. So at 0, it's like 10, 10, 15, 20. Again, you'll see that it like stopped changing, showing that the reaction has stopped, and you will see a plateau, kind of. This isn't a plateau, but I can make it one. But like this. And again, the gradient would be the rate of reaction.